Beautiful, isn't it? This is actually a very minor derivation. I mean, compared to what we're going to do next, this is a minor one actually. So these are facts in trigonometry. I'm going to, I don't know if you can, I think, because I don't want to write here because I'm not too sure my camera extends up to this. I'm going to wait for like 10 seconds and then clean off and then write those identities. Okay, so I'm going to start by saying, now we know three things again. It's interesting how most trigonometric axioms identities comes in threes. Come in threes. It's too small, but you can manage. Yeah, so that's that about it. I'm about to clean all of this off. I'm going to be using these three are powerful. These three are powerful. In my next section, I'm going to be doing, I'm going to call it Prove That. You see, I'm going to solve a bunch. There's this book I got last year, like my physics teacher gave me when he was teaching me. He gave me this book and when I saw the trigonometry question, it's questions of proof. Prove that this equals this, or if this equals this and this equals this, prove this. These are basically mostly when I was doing it with my friend, Michael, intelligent guy. When I was doing it with him, these were mostly the things we used, just these three axioms. And then when you're doing a question, it might look like it doesn't even look like, because it's been a long time that I did this question. So I'm just going to write all of them down, most of them down, and then you might take a whole video, a whole section to do one question because I can't remember how I solved it. I'm going to sit down, I'm going to have a chair here, and then I might be quiet for like 5 minutes trying to figure out how to maneuver something or something like. Because I remember those questions were tough because I really can't remember how to do them. So you're going to watch me sit down and think how I actually solve these questions. So these are the main things that you need to know. So we're going to prove that in our section 3. And then after prove that section, the next video is going to be on summary of all of this, and then maybe I'll do projectile motion or something. Oh, why am I cleaning that? Why am I cleaning that? I'm just gonna write. No. Yeah, I'm gonna clean everything because I need the space. So we've done 4 things now, haven't we? 3 things. We're meant to do 4 things, but we've done 3 things now. We've done negative angles, negative values, trigonometric identities. Now we're going into addition formula or formulae, however you want to call it. Now, the addition formula is like I know most of you must have seen this before. Cosine A plus B equal, cos A cos B minus sine A sine B, and so on the opposite for what's it called, for negative, and then sine, and so on and so forth. But today I'm not just going to show you the addition formula. I'm going to show you how it's derived. Now, this is what I want you to do. Follow every single step. In this circle, that's not a circle. Nothing puts more smile on my face. In this circle, we know something, eh? We know that there is a centroid, a center of the circle. We also know something. Any line we draw from that point, which is the center of the circle, center of the circle, see to any segment, no, any point on the circumference. All of those lines gives you the length of the radius. Let's call this Q. Let's call this. So we know this is R. If we extend, let's draw a diameter. It's not straight. Let's call this P. I'm trying not to clean the circle. Hopefully you can see this blob. Let's say the angle between the x-axis and Q and the length and the radius and the length R from the centroid to Q is beta or B. Let's call it B. And the angle from P from this vector, let's not call it vector, let's go from this line to the x-axis is A. Therefore, we know this small piece is A minus B. Now, if we draw this line, that's the adjacent, because this is almost forming, if you ignore this line, this is almost forming a right angle triangle. So what we can do is we project this point on this plane, on this line. So it's going to be somewhere here. So this is going to be X and Y. If we extend this triangle, we know something. We know that that's R, that's X, that's Y. So sine of B, it's capital letter by the way, is equal to Y divided by R, right? Which makes Y equal to R sine B. Note something there. R sine B is the length of Y, right? But look at something. This is the terminal point. Let's say this is 4 centimeters. At the 4th centimeter of that line, that's the terminal point. I like to think of it as a vector, because if I had J here, it specifies something. So that's the terminal point here. So that's the Y component of this line, okay? So that's the Y component of this line. The X component is going to be defined by cosine. Cosine of B is equal to therefore the X component of this line is given by r cosine b. So we can say something. The point Q is given by coordinate system xy. And we know what xy is. Q is given as r sine, where is it? R cosine b, comma, r sine b. And you know something though. You know that from Pythagoras theorem that this squared plus this squared gives you r squared, and it's true. Square this and this, we already learned that sine squared of any angle plus cosine squared of any angle gives you 1. 1 times r gives you r. So this is the coordinate of Q, which is x and y, which is can be given as r cosine b and sine b. For this one's a little, it's not difficult, it's tricky, it's just, we know what the angle is from here to here. Same thing we're going to do, extend the vertical. So it's going to go there. So this is going to be our x prime, it's going to be our y prime. What is this angle then? We know the angle on a straight line is equal to 180. So let's call this small angle, let's call it rho. Let's call it phi. We know that phi plus a (180). Therefore, phi is equal to 180 minus a. Does that look familiar enough from the last what I cleaned off? Yes, it does. Just so you know. Sine of phi. So to get the y component, we say sine of phi is equal to what sine of phi? Sine of phi is obviously y prime divided by r. Y is going to be a positive number because this is the y-axis, this is the x-axis. So at this point, y is still going to be is still going to be positive. Y-x is going to be negative at this point. So the only time where y and x are negative is in the third quadrant. In the fourth quadrant, it's like it alternates. First quadrant, both positive. If you reflect that at a 180-degree angle, you have them to, that's at the third quadrant, you have them to be what's it called? You have them to be negative. If you reflect that above, if you reflect that with the x-axis, that's this point here, this segment here. Only y is positive and x, and this one you just alternate that, vice versa. Don't want to talk too much. So so sine of phi is given by that. Because it makes no big difference. It's still the same y we're using, so let's not call it y prime. Y prime is going to be down here. X prime is going to be there. So let's call it y divided by r. So the y component is going to be y equal to r sine phi. Y equal to r sine 180 minus a. We don't want 180 minus a, that's in the second quadrant. So y equal to r sine a. Whew. This place is hot. We also know something. If we wanted to do cosine phi, that's equal to x prime, which is a negative number, divided by r. So cosine, that's x prime is equal to r cosine phi. Cosine phi is 180 minus a, so x prime is equal to negative r cosine a. Because x prime is negative, so it's just going to cancel out. So the x component of this line is going to be r cosine A. So P is given by x prime, comma y. P is given by r cosine A, comma r sine A. Don't know if you get that. Let's draw a line from P to Q. That line is going to be PQ, isn't it? So that's the line PQ. I don't know if you've heard about cosine rule there. But the cosine rule states something. The cosine rule states that PQ squared, before I go into the cosine rule, I want to state something. The right angled triangle uses the cosine rule in a hidden way. Look at something. The Pythagoras identity is actually a cosine rule. C A B. So the cosine rule says if you want to know the length of this, square this and square this, and subtract I don't have to say the words anyway. It's going to be the product between these two vectors, or these two lines, multiplied by the cosine of the angle between them. So from Pythagoras identity, we know c squared is equal to a squared plus b squared. From cosine rule, we know c squared is equal to a squared plus b squared minus 2ab cosine, because it's the right angle triangle, cosine 90. Which makes, because cosine 90 is 0, so minus 2ab cosine 90 is equal to 0, which makes this minus 0, which makes no big difference. So that's nothing, but just for clearance, because I want to consider cosine rule also. Okay. So we know PQ squared. This angle here is A minus B. We know PQ squared is equal to what? Is equal to r squared plus r squared, because this vector squared, no, why am I just going to vector? This length squared plus this length squared, which is r squared plus r squared, which is 2r squared. 2r squared is equal by minus 2r squared again, cosine a minus b, no, cosine a minus b. So that's one identity for PQ squared. Oh, I'm sweating, it's really hot here. So I'm just going to make it two more beautiful. PQ squared is equal to 2r squared 1 minus cosine a minus b. Okay, so that's true for PQ squared. We also know something, that if we brought a point below Q such that if we join the line between the point P and the point N, and the point N and the point Q, it gives us a right angle triangle, which means that the angle PNQ is 90 degrees. What that simply means is this: if we have a point here, let's call that N. So the point P to N and the point P, that gives us a right angle triangle. So the angle PNQ, that's the angle from the right angle triangle PNQ, from the triangle PNQ, the angle PNQ is equal to 90 degrees. Therefore, that means this angle is 90 degrees. Angle PNQ equal 90 degrees. We know what Pythagorean identity says. PQ squared is equal to PN squared plus PQ squared. So we know, I can't kneel down anymore, I'm tired. PQ squared. By now you should understand something. By now you should know that we're trying to equate these two together, because I've gotten one identity for PQ squared and I'm trying to get another one. PQ squared is equal to PN squared plus NQ squared. What is PN squared then? PN squared is just this little height here. So it's going to be, look at something, PN squared is just this little height here. So it's going to be this vertical coordinate minus this vertical coordinate. I don't know if you can see it. So because it's this little height. So you have this and this, okay? And you're asked to find, so you have this and this. And you're asked to find just this little piece. So it's going to be this vertical point minus this vertical height, sorry, to give you Pn squared. So Pn squared, but again, I think I should have written this here. I have to kneel down anyway, so how do I write this? So we know PQ squared equal Pn squared. NQ squared. So Pn is equal to this vertical length, and that's for P, that's R cosine A minus R sine B, minus R cosine B. Y NQ squared is going to be for the horizontal. So NQ sorry is equal to R sine A minus R sine B. So we say P, because I'm trying to get space, that's why I had to write that there. So we say PQ squared is equal to Pn squared plus PNQ squared. So that's R cosine A minus R cosine B all squared plus R sine A minus R sine B. I'm tired. All squared. Now this is from here on is just an algebra problem. Like it might be, I don't know if it's going to be tedious, but we could call it's, you can do it in two ways. You can do this part first and do this part secondly, or you can just say call this whole thing small a, call this whole thing small b. So a squared plus b squared. So that's going to be a plus b all squared minus 2ab. But that's going to make it more tedious actually, if you ask me. Because I know what's a minus b. Let's call this a, let's call this b. I know what a minus b all squared is. That's going to be a minus b all squared. That would be a squared plus b squared. You know what, let's just do it. Say, let's do a, I'm actually forgotten this. Yeah, that's going to be a squared plus b squared minus 2ab actually. Yeah. So that's going to be, so we know Pn squared is equal to this one squared, R squared cosine squared A plus R squared cosine squared B minus 2 this times this, r squared cosine A cosine B, and nq squared is equal to r squared sine squared A plus r squared sine squared B. This is just a problem of algebra and expansion. Minus 2r squared sine A sine B. So this plus this, that's going to be okay, that's going to be, let's add these together and these together and these together. So that's going to be r squared pq squared is equal to r squared, that's r squared plus r squared cosine squared, that's r squared cosine squared A plus sine squared A. I don't know if you get that. So pq squared is equal to this one squared, this plus this. So I factored out the r squared plus, and we know what this is, right? We know what that is. Plus r squared times that's cosine squared. Cosine squared B plus sine squared B minus 2r squared cos A cos B plus, actually it's going to be plus, because if you distribute it's going to be minus as well, so you have to put a plus here, so this becomes turns to minus sine A sine B. So we know this is gibberish. This is simply just 2r squared, r squared plus r squared, this is 1. So we have pq squared is equal to two r squared minus 2r squared, let's just write it like this. Let's just factorize everything out once. So that's going to be this 2r squared minus that, so it's going to be 2r squared, open a big bracket, 1 minus cosine A cosine B plus sine A sine B. So this is another equation for PQ squared, so that's equal to equation 2. So now what we're just trying to do in essence is we're trying to get what cos A minus B is. From cos A minus B we can derive what cos A plus B is. So 2r squared, because this is equal to this, 1 minus, this is so difficult to write, tedious, A B A B is equal to, so equation 2 equal to equation 1 is equal to 2r squared 1 minus cosine A minus B. This cancels this. So, I mean, This one will also cancel this one, but like if you're not too sure, just 1, it's like saying 1 minus x equal 1 minus y. You know, if you call all of this y, the 1 minus we just, you know. Anyway, let's just go over it. So, so that'll be, so 1. So let's do it like this. Cosine A, cosine B. Cos A, cos B, plus sine A, sine B is equal to that's going to be 1 minus 1, that's 0. So minus cancels minus. I really don't have to write that. I don't know if you guys should understand that actually. I don't just want any ambiguity with you, so I'm just going to write it explicitly. So that's equal to 1 minus cosine A minus B. Bring this here, becomes a minus 1. Minus 1 cancels that. So you have minus this equal this. Minus cancels, it cancels away. So we have the following. If this is so for minus, therefore for plus is going to be change the sign here. Yeah, so that's that for that. I would have loved to do for sine, but man, I'm tired. For sine, normally you just do, because we know that cosine 90 minus any angle is equal to sine of the angle. Anyway, I'll go over that in the next video. I'm exhausted. Thank you very much. I think this will actually extend. This is section 3, so next video will be like section 3B or something. Thanks.